guys, thanks for coming back again. For those that have subscribed, if you are yet to subscribe, please click on the subscribe button and also on the bell beside it to notify you when we drop our new video. We want to look at electrolysis today, and what does electrolysis implies. The word electrolysis is coined from two words. The first one, which is electrode, and the other one, lysis. The word electro means in Greek what? By electric. Then the lysis means breaking down. So meaning that this electrolysis is talking about breaking down of something by electric current. However, it is defined as the breaking down of a compound by passing direct currents through heat via electrode. That means in order to pass direct current through it, it must be through some rod called the electrodes. How is this done, or how is it achieved? A cell, which is the source of current, is connected to the electrode through which current enters the substance and leave. And the substance we are talking about here, of which we are going to break down, must always be in liquid form. So let's look at the terms used in electrolysis. Terms used in electrolysis. We have the first term, which is called electrolytes. Electrolytes, plural electrolytes. Electrolytes is a substance in which, when it is in the solid state, it doesn't conduct electricity. But once it is dissolved in solution form, or it is molten, or it is melt in its molten form or in its solution form, if it is a material that can be dissolved in water or in any other solution, then it becomes electrolyte. If it is a material that doesn't dissolve but can be melted, then once it gets into its liquid state, either by melting or by dissolving, it becomes electrolyte. It becomes a conductor of electricity. So such substance is regarded to as electrolyte. For instance, the common salt we all use in cooking is an electrolyte because it doesn't conduct electricity in the solid state, but once dissolved in water, it begins to conduct electricity. So it is regarded to as what? The electrolyte. So this is one of the terms. We also have electrodes. Electrodes are two rods, metal rods, inserted into the electrolyte, through which current enters and leaves the electrolyte. Electrolyte is the substance we are breaking down in electrolysis. The substance we are trying to break down to separate into its components is electrolyte, and it has to be in liquid form. So to pass current through the liquid and out of the liquid, we use electrode, two metal rods called the electrodes. So there is a particular electrode through which current enters, and there is another one through which current leaves. So electrode is of two types. We have the cathode and we have the anode. When we have an electrolytic cell, what do I mean by that? An electrolytic cell is an arrangement where we connect all these together, including the cell, which is one of those terms we meant to talk about. The cell, of which is the source of current, is also part of it. So if I have a cell, this is the negative terminal, the positive terminal. I connect the positive terminal through the means of conductor to a rod. Automatically, once the positive terminal is connected to this rod has become anode. So anode is the positive electrode through which current enters the electrolyte. Anode is the positive electrode through which current enters the electrolyte. And at the same time, we can call it the electrode through which electron leaves the electrolyte. It's still the same thing. It is the electrode through which current enters, but electron leaves. Then it is called the what? The anode, positive. Then the negative side of the cell connected to another rod makes this rod a cathode. So cathode is the negative electrode through which current leaves the electrolyte, or electron enters the electrolyte. Simple. So, and we have a container in which the electrolyte is present. So, and then the electrode is inserted. So the whole diagram here is what we call the electrolytic cell. Electrolytic cell. So where this is the cell, which is the source of current, this is the anode, this is the cathode, this is the electrolyte. Electrolytic cell is typically different from electrochemical cell. Electrolytic cell makes use of current to perform a function, which is splitting down of the electrolyte, while electrochemical cell makes use of chemical reaction in supplying current. So that is the difference, and those are the terms used in electrolysis. However, I made a statement earlier that electrolytes conduct electricity only in their liquid state, but not in their solid state. How? Why? What is the explanation behind that? What can we give behind that? Anyway, the whole explanation has been given by the Ionic theory. Ionic theory. Ionic theory. Ionic theory explains that for an electrolyte not to conduct electricity in a solid state, that shows that the particles, which is the ion present in that substance, are held together by electrostatic force. So this force prevents their free movement in solid state, so they are unable to conduct electricity. But once they are dissolved or molten, the electrostatic force between them loses and they gain free movement in solution. Let's take a look at the diagram. So for an electrolyte, once they are dissolved in water, there is free movement of ions. So we are going to have the ion move interlocking with each other. You see this? So are you following? So there is free movement in solution. The ions have free movement once they are dissolved, but in their solid state, they are unable to conduct electricity because they are held together by electrostatic force. But now in liquid state, they have free movement, they can conduct electricity. So that is just the principle. But however, during electrolysis, how does it happen? How does it take place? Because if I am to perform the electrolysis of copper-2 tetrasulfate 6, I'm going to have the positive ion of this in this salt, and I will have the negative ion in this salt, just like we have, which is Cu2 plus and SO4 2 minus. So how am I going to split all the components, elements, and actually get them out separately? So through the electrolysis, very easy. The ionic theory already explains to us that ions of this substance gains free movement once dissolved in water or once molten if it is a material that can be melted. So now, in the process of performing the electrolysis, the rod, which is the electrode, the metal rod, is inserted into the solution. And don't forget what is going on in the solution earlier is that the ions have free movement. So immediately the electrode is introduced into the solution. We have the positive electrode and we have the negative electrode and the positive electrode. So however, it is a normal law that the positive attracts negative and negative attracts positive. So what actually happened during the electrolysis is that The positive ion in this solution, which I'm representing with the ions here, the positive ion here migrates to the anode, to the cathode, sorry, because cathode is positive, so all the positive ion migrate towards this direction, to the cathode. So therefore, they are called cations. So positive ions are called cations because why? They migrate to the cathode during electrolysis. Then we have anions, which are the negative ions in solution. They migrate to the anode, which is positive. So that is positive attracts negative, negative attracts positive. So they lose their free movement here and begin to migrate to their respective positions due to their property of charge. So the property of charge for the positive ion makes them to migrate to the cathode, which is positive, the negative electrode. Sorry. Then the property of the negative ions make them migrate to the positive electrode, which is the anode. So when they get to the anode and the cathode, what happens? So then let's quickly cite an example with CuSO₄. CuSO₄ is a salt that can dissolve in water. So once it dissolves in water, we have the ions, the positive ions and the negative ions in solution. And the positive ion that will be available will be 2, and the negative ion will also be 2, because positive ion gotten from Cu2 plus and the H plus, which is from the water. So we have the negative ion that is present to be OH minus from water and SO4 2 minus from the salt. So these are the ions that are moving freely in the solution. But once the electrodes are inserted into the solution, they all lose their free movement. And the positive ion, which is the H plus and Cu2 plus, begin to migrate to the cathode. While OH minus and SO4 2 minus begin to migrate to the anode. So when they both get to the anode, they fight for preferential discharge, which one to come out first. Then also these, when they get to the cathode, they fight for preferential discharge, which one is to be discharged first. Good. So but Cu2 plus, which is the copper ion, is fortunate to come out first at the cathode. Yeah. Then OH minus is fortunate to come out first at the anode. There is a criteria for which one to come out first to be preferentially discharged in a more professional way. So we have when they both migrate, when the positive ion migrate to the cathode and the negative ion to the anode, there is a preference for discharge. And there are 3 things that are to be considered when choosing or when we're going to talk about the preferential discharge of a ion during electrolysis. So we need to consider the nature of electrodes, we need to consider position of ion in electrochemical series. And we also need to consider the concentration of ion. These are the 3 factors that must be considered when we want to decide which of the anion will come out first or which of the cation will come out first. So nature of electrode in this electrolysis explains that if the type of electrode I'm using is naturally reactive or it has affinity for one of those ions. Okay, take for instance, I'm using Cu2 plus and H plus as an example. If the type of electrode I use, majorly the type of electrode used are carbon rod and platinum rod. But however, sometimes we have some electrolysis that make use of silver rod and so on, but majorly carbon and platinum rods. So if normally Cu2 plus and H plus migrate to the cathode, which will be discharged preferentially, we can decide to look at the property they have. Talking about nature of electrode, none of these ions naturally react with the electrode if it's carbon. So in this case of this electrolysis of CuSO₄, there is nothing like nature of electrode. There are some electrodes anyway that take part in the reaction going on inside the electrolyte. Like when the positive ion migrates here, if one of the ion naturally reacts with the electrode used, so then there is tendency that the ion will be discharged first. There is tendency because naturally, if the electrode has affinity for that ion, irrespective of the position of the other one in the electrochemical series or its concentration, the later will be discharged first. But however, we also have position of ion in electrochemical series. This is electrochemical series, or you can rather call it the redox series. This is for the cation and this is for the anions. So, and according to this diagram, we have increasing preferential for discharge. Increasing preference for discharge. So meaning elements that are lower, which ion is lower in this electrochemical series for the positive, will discharge first. So if you look at the position of Cu2 plus to hydrogen, Cu2 plus is lower to hydrogen, so it could be discharged first. That makes Cu2 plus discharge first before hydrogen when they got to the cathode. So what actually happens at the cathode, we call it cathodic half reaction. Cathode is negative electrode. So this is where electron enters the electrolyte. So the electron that enters through the cathode is accepted by this ion, and this copper ion is gotten as copper solid on the electrode. That means we need to consider how are we going to get the amount of copper that is deposited. We consider the thickness of the electrode. So after the electrolysis, we check the thickness again and the color, the nature. So we see there is a difference that there is an element that has been discharged on it. So however, what happened at the cathode, we call it cathodic half reaction. Cathodic half reaction. What happens is copper 2 plus accepts 2 electrons from the cathode and becomes Cu solid. This is aqueous. And this is 2 mole of electron, that is 2 Faraday. 2 mole of electron is equal to as 2 Faraday. So that is what happened at the cathode. And the reason why copper is discharged first is because of its position is lower in the electrochemical series compared to hydrogen, which is higher than it. So ions that are lower in the series will discharge preferably. So then the negative side, we have the lower one also will be discharged first. The lower one in this series will be discharged first. So considering the distance between OH minus and SO2 minus, OH minus will be discharged first. The hydroxide ion will be discharged first compared to the tetrasulfate 6 ion. So hydroxide ion is discharged first at the anode. So the anodic half reaction shows that we have OH minus plus OH minus, and that gives us H2O plus O. So meaning oxygen is discharged at the anode. So if this reaction is doubled, provided we have 2 here and we have 2 here, so definitely we're going to have 2 then O2. So meaning that oxygen gas will be discharged at the anode. So if you continue to pass current, once the OH minus and the Cu2 plus is finished in solution, then this will be left in solution. That is how it works. Then the concentration of ion, which I've not emphasized on. There are sometimes the amount of hydrogen ion in solution might be more than the Cu2 plus. So that will be an advantage for hydrogen ion to work against copper and be discharged first. So sometimes the concentration of ion also affects. If I have more of hydrogen ion compared to the number of Cu2 plus I have, that can be an advantage for hydrogen to be discharged first. in some electrolysis. So we are going to consider electrolysis of brine, which is concentrated solution of sodium chloride, and see how it goes. So that is electrolysis of brine. Brine is concentrated solution of NaCl. What happened during the electrolysis of brine? Brine is when you dissolve sodium chloride in water, and however, you increase the concentration of the salt, so it's highly concentrated. So we are going to have two positive ions, which is the Na plus and the H plus. Then we're going to have two negative ions, which is Cl minus and OH minus. So here, what actually happens? At the cathode, we just normally what we have explained earlier with ionic theory, the ions have free movement. So once the electrode are inserted, they lose their free movement, and positive ion migrate to the cathode, negative ion migrate to the anode. So when Na plus sodium ion and hydrogen ion got to the cathode, there is fight for also preference, which one is to be discharged first. So, but however, sodium is discharged first. Okay, sorry, hydrogen is discharged first instead of sodium. Irrespective of the concentration of sodium, here concentration of the ion does not even matter. Why? Because the gap hydrogen has given sodium ion in the electrochemical series is too high. So the concentration of sodium does not even have any effect on the preference for discharge at this point. So hydrogen is discharged first at the cathode. Why? Because the gap in the electrochemical series is too high and very far from each other. So despite the concentration of sodium, is unable to come out first. Despite the concentration of sodium, because we're talking about brine, which is concentrated salt solution of NaCl. So despite the concentration of Na plus, it doesn't discharge first. H is discharged first due to the gap in the electrochemical series. So at the anode, at the cathode, we have H plus accepted anyway two electrons, and becomes hydrogen gas is released at the cathode. So we call this cathodic arc reaction. So then the next one, we have Na plus ion in solution left after hydrogen might have been discharged. So however, we can have the anode side also. In the anode side, considering the position in the electrochemical series, I know you would say OH will be discharged first, but no, the gap in the electrochemical series does not even have effect. Cl minus is discharged first due to high concentration. So the concentration matters in the anode. Why? Anyway, because the distance in the electrochemical series is not too high, so then chlorine has more concentration, so it's able to discharge first. So at the cathode, at the anode, I mean, chlorine is being discharged at the anode. So we have Cl minus loses 2 electrons. It becomes Cl2 plus 2 electrons. So what happened at the anode anyway is that the anions, which is negative ion, loses electron to the anode, which is positive. Then when the cation got to the cathode, they accept electron from the cathode. So we can put it in a formula that's okay. In the process of losing electron, that is oxidation. In the process of accepting electron, that is reduction. So the type of reaction that takes place at the cathode is reduction. So we use the formula red cat as a means of memorizing it. Reduction at the cathode, red cat. So then at the anode, there is oxidation because you lose electron to the anode, which is positive electrode. So we call that anox. Anode oxidation, reduction at the cathode. So this formula represents, if you are asked that what type of reaction takes place at the anode, then it is oxidation. What type of reaction takes place at the cathode, then it's reduction. That is anox and red cat. So, however, I've explained what actually happens in the electrolysis of brine, and that is it. So, what are the ion left after H has been discharged first and Cl minus has been discharged first. I'll be left with Na plus with OH minus. So which gives us NaOH. That's sodium hydroxide, a base. So meaning that this electrolysis of brine we could produce is another means of producing sodium hydroxide. Yeah, it's another means. So that is that on the electrolysis of brine. Let's look at the relationship between the amount of current passed. We have just been emphasizing on what is going on within the electrolytes and electrodes. We are yet to talk about the source of the current. The source of the current, which is the cell, is passing currents for a period of time, and the current passing for a period of time produces charge, because charge is the product of the current and the time for the current to pass through the substance. So how does it have effect on the quantity of hydrogen or whatever that might be discharged during electrolysis? How long, when you pass current in a short period of time, does it mean that the whole element, the whole ions has been discharged or whatever? So what is the relationship between the amount of current you pass, the time, and the mass of the elements that will be discharged during the electrolysis? So then we'll talk about that. So that's Faraday's law. So we call that Faraday's law of electrolysis. Faraday's law of electrolysis. So Faraday gave two laws for electrolysis. We have the Faraday's first law and we have the Faraday's second law. The Faraday's first law tells us the relationship between the mass of element discharge and the quantity of charge passed through it. However, we have to tell us what charge is before we proceed on Faraday's first law. So if I pass a current I, which is current, through an electrolyte for time t, there is a charge developed in that process. So and that charge is given as Q, which is charge. This charge is measured in coulomb. Measured in coulomb. Currents in ampere, and time, as you know, in seconds. So the charge could be determined by IT. So current times time is the charge developed when you pass the current. So what Faraday's first law tells us is that the quantity of the mass of elements discharged during electrolysis is directly proportional to the quantity of charge that passes through the electrolyte. So the mass of the element that will be discharged, during electrolysis is proportional to the quantity of charge, meaning that if I want more of elements to be discharged, then I will pass current for longer time. So that means the higher the mass, the higher the time the current flows. The higher the time and the current you pass, you understand? So that is the charge. So from here we have M equals ZQ. So Z is a constant called ECE, electrochemical equivalence. Electrochemical equivalence. So substituting the value of Q, which is IT, now we have M equals ZIT. So this is referred to as Faraday's first law of electrolysis. Good. The second law, we're going to solve a question that involves the two altogether. The second law states that, it tells us the relationship between the charge on ions of elements and the relationship between the charge and the amount of charge on the elements, on the ions of the elements, and the amount of current or amount of charge that will be passed to give 1 mole of the element. So what Faraday's second law states is that if the same current is passed through two different electrolytes, two different electrolytes. Let's take into consideration NaCl, CuSO₄. The same amount of current is passed through them with the same amount of time. The relative number of elements discharged, the relative number of mole of element discharged, the relative number of mole, that's relating the number of mole of elements discharged to the number of mole of elements discharged, that's the relative number of mole of elements discharged, is inversely proportional to the charge on the ion of those elements. Is inversely proportional. The relative number of moles, the number of moles of element Na that will be discharged, and the number of moles of element Cu that will be discharged in the process is inversely proportional to the charge on the ion of this element. That is what Faraday's second law states. So what does that mean? However, we have elements that are univalent. Univalent means they have only one charge, positive charge or negative charge. So we have Na plus is univalent, and we have Cu2 plus is divalent, and we have Al3 plus is trivalent. That's considering the charge they have. Yes, their valency. That's their valency. So what Faraday's second law is trying to say is that if I pass the same quantity of charge into this solution that contains this ion, the number of moles of element discharged is inversely proportional to the charge on them. So meaning that I will just say it in a nutshell. 1 Faraday, this is 1 Faraday, which is equals to 1 mole of electron, and is also the same thing as 96,500 coulomb of charge. We'll be able to discharge 1 mole of univalent ion. 1 mole of univalent ion. So meaning 1 Faraday will discharge 1 mole of Na plus. So 1 Faraday discharges 1 mole of Na plus. Na plus. So what is trying to say in relationship with other relatively means 2 Faraday will now be required. We discharge 1 mole of Cu2 plus. Can you see this? So relative to it, they are inversely proportional because 1 mole discharge 1 mole of this because the charge on it is +1. But 2 mole of Faraday discharge 1 mole of this because of the charge at the top. So meaning that 1 mole of this, Al3, will be discharged by 3 moles of Faraday. 3 Faradays discharge 1 mole of Al3 plus. So that is what Faraday's second law is talking about. So let's look at a question that we cover everything. So if I say that find a current of 0.2 ampere, this is 0.5 ampere, is passed through a solution of copper salts for 10 minutes. Determine the mass of copper discharged. Determine the mass of copper discharged. Good. We know that a current of 0.5 ampere is passed through a solution of copper salt for 10 minutes. So we're supposed to be given the additional information that 1 Faraday equals 96,500 coulomb, and at the same time the mass of copper is 64. So to calculate the mass of copper that will be deposited, we can actually use, provided we know the electrochemical equivalence of copper, we can use M equals ZIT. But in the absence of the electrochemical equivalence, which is not given in the question, so we can use the other method with respect to Faraday's second law and first law altogether. So we know that 1 Faraday will discharge 2 moles, or probably, if I say this, that 1 Faraday, this is 1 mole of copper that will be discharged by 2 Faraday. So meaning 2 Faraday will discharge 64 grams of copper, which is 1 mole of copper. 1 mole of copper is 64 grams. So and because the charge of copper is Cu2+, so definitely 2 Faraday will be discharging this 64 grams, which is 1 mole of copper. So however, the quantity of charge here is Q equals IT. Don't forget I is equals to 0.5. Then T equals 10 minutes, which is 600 seconds. So quantity of charge will now be what? 0.5 times 600, which is 300 coulomb. 300 coulomb. So if 2 Faraday discharge 64 grams, that means 2 times 96,500 discharge 64 grams, definitely 300 coulomb. These are charges. We discharge what? X gram. So from there, I can take it that 2 times 96,500. So cross multiplying, I'm going to have 64 multiplied by 300. 64 multiplied by 300 will now be equals to 2 times 96,500. So that gives us 193,000 X. So the mass of copper that will be deposited is going to be 64 times 300. So let's look at that. 64 times 300. So that is 19,200. All divided by 193,00. So that gives us 0.099 grams. So meaning the mass of copper that will be deposited if a current of 0.5 ampere is passed through the solution of copper salts, the amount of copper, not silver, that would be deposited if a current of 0.5 ampere is passed through the solution of copper salt for 10 minutes would be 0.0099 gram. So as it is. So that is just how the analysis is being done. Thanks for watching. Please subscribe to our YouTube channel. It's free.